Foundation Robotics is officially going full humanoid. Wheeled robots are out, and legged robots are the entire future. And if that wasn't enough to shake up the robotics world, Wandercraft just locked in $75 million to go absolutely massive with their AI-powered exoskeletons and humanoid robots. So yeah, AI robots are evolving fast, faster than most people realize. Welcome back, friends. Alfie here with another major update. Foundation Robotics is going all in on legged humanoids, while Wandercraft just secured a massive $75 million to scale up its groundbreaking exoskeletons and launch its first full humanoid robot. You're watching the AI Nexus, your trusted source for the future of intelligent machines. Let's go. Let's start with Foundation Robotics, because their pivot is one of the most decisive moves we've seen from any robotics company in the last year. Just a month ago, they proudly shipped out their very first production robot, the Phantom, to a real customer. That robot had wheels, was built for real-world factory work, and it marked the company's first step into commercial deployment. But now, Foundation just dropped new footage showing Phantom operating in that customer's facility, and in the very same breath, they made it clear. They're done with wheels. That's right. Foundation is officially ending production of their wheeled robots and will phase them out entirely by the end of the year. That's a bold statement, because think about what that means. A robot company finally gets a product to market, lands their first customer, and instead of doubling down, they pull a 180. Why? Because they believe the future isn't wheeled. It's legged. It's humanoid. It's bipedal machines that can navigate the same spaces we do without needing ramps, flat surfaces, or any special accommodations. Now, Foundation isn't exactly abandoning what they've built so far. That customer deployment? It was still a huge success. The Phantom showed real capability. But Foundation is looking at the bigger picture. They know that to build robots that can work in truly human environments, in warehouses, factories, homes, or offices, you need legs. You need humanoid systems that can handle stairs, thresholds, tight corridors, and unexpected clutter. You need machines that walk like us, see like us, and move with enough fluidity to be genuinely useful alongside people. And that's where their new focus lies. This shift isn't coming out of nowhere. Foundation Robotics has been working behind the scenes on legged mobility for some time. They've hinted at prototypes, internal testing, and design overhauls. But this is the first time they've put a clear stake in the ground. Wheeled units? Phased out. Entire focus? Legged humanoid robots. That puts Foundation squarely in the race with some of the biggest names in robotics today: Figure, Tesla, Agility, 1X, Apptronik. But what makes Foundation's move unique is that they're not just talking, they're executing in real time. 1 month, production robot shipped. 1 month later, full strategic pivot, footage of robots in action, and a total commitment to the humanoid vision. It's a sign of how fast this industry is moving, and how quickly companies have to adapt if they want to stay relevant. Now, pivot over to Wandercraft, and the story gets even bigger. If you've been following the robotics space, you've probably heard their name before. They're the Paris-based company known for building some of the most advanced robotic exoskeletons in the world. Machines designed not just to assist movement, but to restore it entirely for people with mobility impairments. And they just raised a whopping $75 million in Series D funding. Let that number sink in. $75 million. That's not seed money. That's not an experimental grant. That's serious capital from major backers, including Renault Group, Bpifrance, and the European Investment Bank. These aren't just tech dreamers. These are industrial, economic, and governmental powerhouses placing big bets on Wandercraft's vision. So, what's the money for? First up, Wandercraft is launching something that could totally redefine assistive robotics. A personal-use, self-balancing exoskeleton called Eve. That name's not random. It's the first of its kind. Until now, most exoskeletons required crutches or support. But Eve? It balances itself. It walks on its own. And it's built for real people to use in real life, outside of hospitals and labs. They're aiming to launch it by 2026, and when they do, it could change everything for people with spinal cord injuries, neuromuscular disorders, or stroke-related mobility loss. This isn't just a medical device. It's a wearable robot that gives people their independence back. And Eve is just the beginning. Wandercraft is also pushing to expand clinical use of their existing Atalante X platform, a robotic walking system that's already being used in rehabilitation centers across Europe and the US. This device doesn't just assist movement. It trains the user, simulates natural gait patterns, and offers real-time feedback. It's powered by AI, deeply customizable, and now, thanks to this funding, it's poised to scale like never before. But here's where it gets even more exciting. With all the attention on exoskeletons, Wandercraft is now also stepping directly into the humanoid robot arena. That's right. They're developing a fully autonomous humanoid robot called the Calvin 40. And this isn't some distant concept or pie-in-the-sky vision. It's already in the works. Calvin 40 is designed with Wandercraft's deep biomechanical expertise baked in. Their exoskeletons already simulate human walking with uncanny precision. Now they're taking that same tech and applying it to a fully robotic system that can walk, balance, and eventually perform useful tasks in human spaces. So on one side, you've got Foundation Robotics going full humanoid and ending wheeled robot production entirely. On the other, Wandercraft is not only building life-changing exoskeletons, but stepping into humanoids with a war chest of fresh funding and institutional backing. And when you look at both companies side by side, a bigger picture starts to emerge. This is the era of convergence. We're seeing the lines blur between assistive robotics, industrial automation, and general-purpose humanoids. It's not just about robots doing factory work anymore. It's about embodied intelligence, AI systems that can move through the world the way humans do, with balance, adaptability, and awareness. Foundation and Wandercraft represent two ends of that spectrum. One started in industrial applications and is moving toward general-purpose humanoids. The other started in assistive tech and is evolving into full-bodied robotic systems. And they're both powered by the same fundamental shift: AI. Think about how foundational this is. Foundation Robotics is ditching rule-based robotics in favor of AI-native systems. Wandercraft is training intelligent gait engines using real-world movement data. Both companies are leveraging machine learning not just to guide robots, but to define their behaviors from the ground up. This isn't about pre-programming a robot with specific motions. It's about giving it the tools to learn from the environment, adjust in real time, and execute complex behaviors fluidly. That's the leap. That's what makes these robots different from the clunky machines of the past. Let's put this into context. For years, robots have been confined to highly structured environments. Assembly lines, controlled labs, repetitive tasks. Why? Because they couldn't deal with change. But humans don't live in structured environments. We deal with uncertainty, imbalance, complexity. That's why humanoid robots have always seemed like science fiction. They require an entirely different level of perception, control, and intelligence. But now, companies like Foundation and Wandercraft are cracking that code. And it's not just about walking. It's about integrating vision, planning, and motion into a seamless feedback loop. It's about learning from experience. It's about adapting on the fly. These are capabilities that used to be the domain of animals, and now, increasingly, they're being embedded into machines. Now, here's the thing. This shift isn't just technical, it's strategic. Both companies are positioning themselves for the long game. Foundation is making a clean break from legacy systems to focus entirely on future-ready designs. Wandercraft is building a product pipeline that serves clinical, personal, and industrial markets simultaneously. And because they're building intelligent, software-defined robots, they can iterate fast. They can deploy updates, refine behaviors, and scale their platforms in ways that weren't possible before. That agility is going to be critical as demand for real-world robotics continues to explode. We're not just talking about helping people walk again or replacing warehouse workers. We're talking about a complete rethinking of how physical labor, mobility, and embodied intelligence are handled in society. And here's what makes it even more compelling. The economics are finally lining up. For years, humanoid robots were dismissed as too expensive, too unreliable, or too gimmicky. But now, With breakthroughs in AI, better hardware, and smarter designs, the cost curves are bending. Just like smartphones, drones, and electric vehicles, the tech is reaching an inflection point. One where scale becomes not only possible, but inevitable. Companies like Figure have already talked about driving costs down 90%. Now Wandercraft is building high-impact devices that could be affordable for hospitals and individuals. And Foundation's Pivot signals they're ready to compete on both performance and price. We're at the beginning of a robotics arms race. But this time, it's about who can make the most useful, scalable, intelligent, and human-ready machines. So what happens next? If you're a robotics company right now, you have two choices. Either adapt to the humanoid revolution or get left behind. The bar has been raised. AI-native design isn't optional. Legged mobility isn't niche. These are becoming table stakes for anyone who wants to play in the future of embodied AI. And if you're a developer, researcher, or engineer, now is the moment to get involved. This isn't a future that's arriving slowly. It's accelerating, with real funding, real deployment, and real-world results happening right now. Foundation and Wandercraft aren't just participating in that acceleration. They're helping to lead it. So keep your eyes on these companies. Watch how quickly they move. Because if the past few months are any indication, the next wave of updates could completely change the game again. AI robots aren't just evolving, they're transforming. Fast. And if you're wondering where the next leap is coming from, you're probably already looking at it. And if you think that was impressive, buckle up. Because what Digit from Agility Robotics pulled off might just redefine what we expect from humanoids. Their humanoid robot, Digit, didn't just walk or carry something around. It listened to a natural language request, figured out what it meant, decided which ingredients were needed, searched the environment, and collected the items. All on its own. This wasn't a controlled lab test. It was a real-world scenario that required understanding, reasoning, navigation, and physical manipulation. The kind of things humans do effortlessly and robots have struggled with for decades, until now. 4 words, that's all it took. A person said, "Bring me the ingredients to make pasta," and the robot moved. No buttons pressed, no joystick, no technician in the back. Just a human voice and a humanoid machine that understood exactly what to do. So let's unpack this, because what just happened isn't just a quirky robot trick. It's a glimpse into the near future of service robotics. A future where robots don't just follow instructions, they understand them. First, let's talk about the robot itself. Digit has already made headlines in recent years for its elegant, bird-like walking gait, its role in logistics at Amazon, and its impressive balancing and recovery capabilities. But this new demonstration takes things to an entirely new level. This wasn't about stacking shelves or walking in circles. This was about context. When Digit heard, "Bring me the ingredients to make pasta," it had to understand what that meant. And that's not as simple as it sounds. Unlike a traditional robot arm on an assembly line, Digit wasn't given a checklist. It had to interpret the goal, making pasta, and figure out what that entails. Think about what goes into that. First, Digit had to determine what ingredients are typically used to make pasta. Does that include dry pasta, sauce, garlic, olive oil, maybe some vegetables or cheese? That requires a knowledge base, a combination of pre-trained data, logical reasoning, and possibly even preference weighting based on the environment it's in. Digit had to identify what the request actually meant before it even moved a single step. Then came the hard part: execution. Once the robot understood the items it needed, it had to search for them. That means scanning its environment, identifying objects using computer vision, differentiating between similar items, and handling occlusion, meaning if something's partially hidden or facing the wrong way, Digit still had to figure it out. That's something that has traditionally tripped up even the best robots in the lab. And it wasn't operating in a sterile, fixed environment. This was not a demo in a lab with neatly placed markers or labeled items. It was a naturalistic setting. Just like you or I might navigate a kitchen or grocery aisle, Digit had to make decisions in real time. Do I go left or right? Is that spaghetti or fettuccine? Can I carry this item while also grabbing the sauce? It even had to coordinate its physical body. Digit doesn't have hands like a human. It has uniquely designed arms with simplified grippers, optimized for stability and utility, not delicate manipulation. So every item it picked up required some decision-making on how to grasp, lift, and balance it while continuing to walk. And keep in mind, Digit walks bipedally. That means balance and locomotion are already complex on their own, even without carrying things. Now here's where it gets even more interesting. This wasn't a single hard-coded routine. The entire point of the demonstration was to show generalization. Digit wasn't told exactly which items to grab or where to go. It used onboard intelligence and perception to decide. And the language command it received wasn't robotic either. It was natural language, just like someone might ask a roommate or an assistant. That's a massive leap in how humans and robots can interact. Up until recently, if you wanted a robot to do anything, you had to be specific. You'd have to program exact coordinates, define the object parameters, create a rigid script. But now we're seeing a turning point. Robots like Digit are being trained to understand intent, not just instructions. They're beginning to reason, to plan, to decide. This kind of capability is made possible by the fusion of physical robotics with advanced AI models. Natural language processing, scene understanding, motion planning, and visual recognition all have to work together in real time. It's like giving a robot a brain, a nervous system, and a pair of legs, all controlled by something that's learning to think. That's why this moment matters. It's not just that Digit did something cool. It's that the task it performed required dozens of different skills to come together in harmony. It had to listen, reason, move, manipulate, adapt, and respond, all in response to a very human request. That's not a stunt. That's intelligence. Now, let's think bigger. If a robot can take a vague request like, "Bring me the ingredients for pasta," and turn it into a series of successful physical actions, then we're looking at a future where robots can be genuinely helpful. Not just in factories, but in homes, stores, restaurants, hospitals, and public spaces. Picture a world where humanoid robots assist elderly individuals in their homes. They don't need to be told every detail. You could say, "I want to make a salad," and the robot would fetch the ingredients from the fridge. Or in a retail setting, you could tell the robot, "Help this customer find a red jacket," and it would understand not just the words, but the intent, guiding, assisting, even engaging in conversation if needed. Agility Robotics is clearly thinking in this direction. Their design philosophy for Digit has always emphasized human-centric environments. In other words, they're not trying to redesign the world for robots. They're designing robots that can navigate our world the way it already is. That's a huge shift from the traditional robotics model where environments are tightly controlled. By equipping Digit with natural language capabilities and autonomous navigation, they're showing what's possible when machines begin to understand human goals in the way we naturally express them. That's what sets this demonstration apart. There's also something psychologically powerful about it. Watching a humanoid robot respond to your voice, turn its head, walk across the room, and return with something you asked for, it taps into something primal. It's the same feeling that science fiction has teased for decades. The dream of a mechanical assistant that understands you. Not just follows commands, but understands you. And yet, this isn't a far-off dream anymore. It's not just being imagined in books or movies. It's happening, right now, today. But let's be real for a moment. There are still limitations. Digit isn't as fast as a human. It's not going to win a race against a warehouse worker. Its hands are still relatively basic. It's not going to julienne carrots or open a jar of sauce anytime soon. But none of that takes away from what it can do. Because autonomy, real autonomy, is harder than anyone outside the field realizes. And what we just saw was a working example of it. The next logical step is scale. Right now, this kind of demo is still carefully staged, even if it's real world. But imagine what happens when these capabilities get rolled out to multiple robots in multiple locations, performing various tasks for real customers. That's where things get exponential. Agility Robotics already has plans to deploy Digit at scale, especially in logistics and retail. But this kind of demo opens up entirely new categories: smart kitchens, home robotics, elder care, customer service. The technology behind this could be licensed, adapted, and expanded in ways we haven't even imagined yet. There's also the matter of safety, and Digit's design addresses that head-on. Unlike some industrial bots, Digit is lightweight, has a soft exterior, and is meant to coexist with people. Its movements are deliberate and non-threatening. It's not there to replace human interaction. It's there to enhance it. And here's something else worth considering. If a humanoid robot can understand language, navigate unpredictably arranged environments, and solve physical problems in real time, then we are entering a period where robotics isn't just catching up with humans. It's complementing us. You don't have to train for hours to teach a robot how to help you. You just speak. The same way you'd speak to a colleague or a friend or a family member. So the next time someone says robots are still decades away from being truly helpful, point them to this moment. To Digit, to that simple phrase, "Bring me the ingredients to make pasta," and to what happened next. Because what we just witnessed isn't just a step forward. It's a signal that the age of intelligent humanoid helpers isn't coming. It's already knocking on the door.